It's the first French ship to reach the North Pole, and the only one equipped to power through the thickest Arctic ice and the churning seas of Antarctica. Come aboard the Commandant Charcot. For 6 years, a massive construction project across Europe engaged hundreds of engineers and workers. This vessel, part cruiser, part crusher, demanded a new way of thinking about what a ship could do and how to get it done.
This is a huge, absolutely insane project. It's something that exceeds anything ever accomplished in the maritime industry.
Now we've got our tickets to board this astonishing ship and uncover its secrets on a 10-day journey around the Svalbard archipelago, 800 miles from the top of the world.
2 bears to port side.
Alongside the ship's captain.
What was our initial course heading?
And his chief engineer.
Here, we're at the engine control room. We've got a 3D screen that lets us review the ship's blueprints.
We're granted exclusive, unprecedented access to the ship's most intricate workings.
If these pumps fail, the temperature inside the ship will drop at an alarming rate. It's crucial.
Through computer-generated images and first-hand accounts from the ship's designers, you'll discover why the Commandant Charcot stands in a class by itself, uniquely able to navigate the treacherous waters of both the North and South Poles.
Navigation in polar waters is the most complex navigation that can be encountered.
What technology enables the vessel to navigate in reverse and carve its own path through the ice?
The ship features a unique airplane wing designed at the stern, which enables it to push away ice blocks once they've been crushed by the propellers.
How can its hull withstand the punishing pressure of the ice?
We can see that the metal is thicker here. It's called the ice belt.
And how can it produce its own electricity and its own drinking water to remain in total autonomy in the remote seas when there's no one to call for help?
The ship has a 2-month autonomy in polar zones with 0 waste discharge.
Let's embark on the Commandant Charcot for a thrilling, chilling adventure in the heart of the ice floes and discover this exceptional, already legendary ship. Longyearbyen, a town of 2,400 inhabitants, the northernmost city on the planet. The capital of Svalbard, a Norwegian archipelago consisting of about 30 islands, located just 800 miles from the North Pole. Off the coast, in the heart of the Arctic Ocean, a one-of-a-kind vessel has just set sail, the Commandant Charcot. Measuring 492 feet long and weighing 30,000 tons, the Commandant Charcot is the first cruise ship ever built with an ice-breaking function. Capable of tackling even the thickest ice, this next-generation vessel exhibits a revolutionary design and is equipped with cutting-edge technologies. Its design and construction have led to one of the most exceptional adventures in the history of navigation.
It took 6 years to go from the idea of this somewhat crazy project back in 2015 to the completion and delivery of the ship in July 2021. During that time, there was a lot of imagining, designing, building, and testing of this extraordinary vessel. It's a massive, insane project. It's a UFO. It exceeds anything ever accomplished in the maritime industry. The construction of the ship involved several thousand people across Europe, with the hull being built in Romania on the Danube Delta. Then towed to Norway, where the ship was completed, including all the public spaces and cabins. The shipyard itself employed several hundred people to finish the vessel.
Mesdames et messieurs, ici le commandant. Nous allons procéder à un exercice obligatoire.
For this cruise to Svalbard, the ship is carrying 215 crew members and 245 passengers. including avid fans of the far north and scientists. The itinerary includes expeditions on land and at sea to discover completely wild species and places, as well as sampling and measurements in real-life conditions to support studies devoted to the Arctic Ocean's ecosystems. It's a new type of hybrid cruise that only the Commandant Charcot is currently capable of pulling off. The journey, a circumnavigation of Spitsbergen, the main island of the Svalbard archipelago, to reach the island of Northeastland, classified as a nature reserve and covered by the largest glacier in Europe. It's one of the most remote territories on the planet. To take passengers to such inaccessible places, engineers had to come up with solutions to allow the ship to navigate in waters that a traditional vessel would be unable to face. Sea ice forms when the temperature of salt water reaches 28.8 degrees Fahrenheit. At that point, the water begins to freeze and a thin layer of ice forms on the surface of the ocean. Depending on the outside temperature, winds, and ocean currents, the thickness of the sea ice can range from just a few inches to almost 13 feet in the areas closest to the North Pole.
To design the ship, it was necessary to have a thorough understanding of the operating temperature, ice thickness, and surroundings, especially the obstacles. This included knowledge of the Arctic ice pack, a highly heterogeneous environment consisting of different types of ice plates, such as intact, first-year, and multi-year ice. The older ice gets, the harder it becomes, and it is increasingly difficult to break it down. Additionally, the ship had to be capable of navigating through ice ridges, which are formed when drifting ice plates collide and create underwater ice mountains, reaching up to 33 feet thick. The boat had to be able to cope with it.
The icebreaker classification groups 7 categories of vessels based on the type of ice they can face and the period of year they are authorized to navigate. Only Russian nuclear-powered vessels are classified as PC-1, while others are classified between PC-3 and PC-7. Captain Charcot's vessel is classified as PC-2.
The Commandant Charcot vessel is truly exceptional, as it is the world's first ship to have a Polar Class II rating. It also demonstrates the best ice maneuvering capabilities of any vessel in the world today.
The name of this exceptional vessel was chosen as a tribute to Jean-Baptiste Charcot, a physician, naval officer, and one of the greatest polar explorers in history. Like the sailor after whom it is named, the Commandant Charcot has already navigated the most extreme polar seas. During its test journey in September 2021, it became the first French vessel to reach the geographic North Pole. It has also sailed in remote areas such as the Scoresby Strait, east of Greenland, and the Weddell Sea in Antarctica, some of the most remote areas on Earth. For this expedition to the Svalbard archipelago, the vessel is under the command of Patrick Marchessault.
We have entered the pack ice that drifts all around the North Pole. We are experiencing Arctic weather. A cloudy sky, a bit of fog. This is the atmosphere of polar explorations. We are currently cruising at 12 knots, and we can barely feel the movement of the ship through the ice. With this type of vessel, we are able to push beyond the limits and explore uncharted territories, new to us but also to the world.
After rounding the island of Spitsbergen and passing through the Hinlopen Strait, the Commandant Charcot approaches the Wallenberg Fjord on the southwest coast of the Northeast Land. This is an opportunity for Captain Charcot to show us the unique hull of the vessel.
The vessel's reinforced hull is built to withstand the harsh conditions of ice navigation. You can see the extra thickness of steel there, which is what we call the ice belt. This means that from there down to a certain depth, the hull is 1.8 inches thick of steel, while a normal boat only has 0.4 inches of hull thickness. You can also see the ribs of the boat, called frames, which are spaced 16 inches apart. For a typical boat, this would be around 40 inches. This gives the vessel an extremely reinforced hull for navigating in ice. Additionally, the bow has 2.4 inches of steel thickness at the front, making it certified for navigation in all Arctic ice in the summer.
Ice can be incredibly tough. Ice from a glacier, which is compacted ice sometimes from 10,000 years ago, is very blue ice with no air inside. It's like floating blocks of concrete. So if the ship hits it, the vessel has to be able to withstand the impact. That's why special steels are used, which are more resilient and thicker than regular steels, with more numerous and closely spaced frames in specific areas like the front, back, and along the ice belt of the ship, places where anything that could damage the boat could hit. The sides are also reinforced to withstand compression when entering the ice, which is why we have a highly reinforced ice belt.
The hull of the Commandant Charcot has a completely new design, in addition to its reinforcements. Unlike classic icebreakers with a bow shaped like a blade, the Commandant Charcot has a much more rounded one.
The navigation through ice is actually smooth, contrary to what one may imagine with the functioning of icebreakers, historically equipped with very pointed stems that would slice through the ice like a knife. The uniqueness of the Commandant Charcot is its specially designed hull shape, intended to be as efficient as possible while penetrating the ice. The ship's weight allows it to break the ice gently, using a stem that is rounded and curved like a banana, enabling it to climb onto the ice surface. The weight breaks the ice in small pieces around the entire perimeter of the stem, similar to breaking a chocolate bar into small pieces. This method requires less power, making the vessel very efficient using its weight and with its unique hull shape. When sailing on the Commandant Charcot, the encounter between the ship and the ice is quiet, without any disturbance.
Another unique feature that enables the Commandant Charcot to navigate through the pack ice lies beneath its hull. Conventional vessels feature a stern-mounted propeller for propulsion and a rudder for steering. Conversely, the Commandant Charcot is equipped with two electric motors, known as azipods, that turn forward-facing propellers. These two motors can rotate 360 degrees.
The Commandant Charcot doesn't use a rudder for steering. It relies on the pods to both propel and direct the ship by rotating. These pods are the strongest available.
A 5-blade propeller has been installed on each pod, which serves a vital function.
The azipod propellers must be capable of crushing any ice blocks that come into contact with them. The greatest risk is that one of these blocks could strike the pods or the underwater engine supports, the turrets, leading to vibrations and damaging their seals. Thus, it is essential for the azipod propellers to remain in operation at all times and break up any incoming ice. Subsequently, these broken ice pieces need to be pushed away from the pods. For this reason, there is a highly specific design at the rear of the ship, shaped like an airplane wing, that pushes the ice aside after it has been partially crushed by the propellers.
The propellers were designed with sufficient strength to withstand contact with ice. Prior to their installation, they underwent testing in a small-scale model in a basin to ensure proper functionality and the absence of vortexes. Vortexes are large air bubbles created by the propellers that can impact both passenger comfort and the ship's structure, possibly leading to destructive outcomes.
The Commandant Charcot's two propellers were made from ultra-tough stainless steel that can resist the shock of ice navigation. Weighing in at over 300 tons each, the ship's two propellers have blades that weigh a whopping 7 tons each.
When navigating through a flow of ice, the ship makes physical contact with the ice, causing the block of ice to roll along the hull to one side or the other, resulting in a sensation similar to turbulence on an airplane. It's a comparable feeling.
On the bridge, the captain maneuvers the azipods positioned beneath the hull using a pair of joysticks. They enable the captain to alter the orientation of the pods, thereby adjusting the ship's course, and to manage its speed with remarkable accuracy.
Is it confirmed, Polar Bear? They're not far. Is it confirmed, Polar Bear? At 9 o'clock. All right, we'll take care of it. 2 bears to port side. Do you see them or not? Over there. Okay, let's go. What was our initial heading again? Despite its imposing size, the ship has exceptional maneuverability. With a gentle touch, we can position it precisely where and how we want it.
Okay, I got one swimming.
Where?
I will show the direction.
Yes, tell me.
It's going up.
Okay. Okay, yes, I can see that, yes. Wait.
Ready, my direction.
This ship is so nimble, it's like a spinning top.
The special shape of the hull and the azipod's pivot capability enable the ship to maneuver out of the most difficult situations.
If the ice pack is too thick and the ship cannot make headway despite its maximum power, there are 2 options available. One is to do some ramming by performing a bit of reverse maneuvering and then launching the ship forward with more speed to break through the ice pack. If this doesn't work, then we perform a maneuver to turn the ship 180 degrees and position the azipods to face the ice pack. We then bore our way through the ice using the propellers.
In September 2021, the vessel underwent testing in the Arctic under the most extreme conditions. Its unique reverse navigation technique, utilizing the azipods as ice-cutting tools, proved its capability to make headway in ultra-compact ice. It even managed to bore through a 49 feet thick ice wall in only 20 minutes, demonstrating the ship's exceptional abilities. After sailing close to the shores of Northeast Land, the ship set a course towards the north. it has just surpassed the 81st parallel and reached the northernmost point of its voyage. Despite it being June, most of the ocean's surface is covered by ice. The captain is vigilant on board, continuously adapting the ship's course to steer clear of obstacles and carve a way through the ice.
We take caution to steer clear of glacier ice, also known as bergy bits or growlers, which are fragments of icebergs that are considered hard ice. We aim to avoid hitting this kind of ice because the collision could be uncomfortable or even damaging. The ship is specifically designed to navigate through sea ice and not glacier ice, as it may cause damage to the propeller blades, for example. It's our responsibility to keep a lookout and visually determine the type of ice we're encountering, so that we can maneuver through it wisely.
Satellite maps received on the bridge give a bird's-eye view of the ice zone the ship is crossing, but they're often several hours out of date. Since the pack ice are constantly shifting, the ship relies on an essential tool on board. Housed in a specially designed compartment at the front of the vessel, a helicopter. Its purpose is to conduct survey missions and identify the most favorable passages for navigation.
Sometimes the ice charts aren't accurate, so we take out the helicopter to check the ice conditions. This helps the captain find the safest route through the ice. It's a precautionary measure that gives him a bit of an advantage.
As he's flying, he sends us turning points and suggests channels to take to ensure we navigate through the right path. It's much easier to see from above. He can go about 30 miles ahead. It helps us make progress faster. It saves us valuable time and energy. The helicopter consumes fuel while it's flying, but obviously less than we do weaving through the ice.
Conserving energy is a constant challenge when embarking on a 15-day cruise in complete self-sufficiency in the Arctic Ocean, an area so remote from the rest of the world. To propel a 30,000-ton vessel through the icy waters, Commandant Charcot's 2 azipods were outfitted with extraordinary power. Each azipod boasts a staggering 17 megawatts, resulting in a total of 34 megawatts of power. These 2 azipods are electric motors fueled by a genuine onboard power plant. This intricate machinery is fitted with the latest and greatest technology. 2 tanks of liquefied natural gas, situated directly above the hull, supply power to 6 generators spread across 2 engine rooms. These generators produce all the electricity necessary to operate the ship. Electricity is directed to 2 propulsion rooms located at the stern of the vessel to power the azipods. These rooms house the systems responsible for powering the propellers and enabling the pods to rotate a full 360 degrees. These ultra-modern installations were purposefully designed to meet the most challenging requirements of polar navigation. Hugues de Camus, the head engineer, takes us down into the bowels of the Commandant Charcot. He granted us exceptional access to uncover every secret of this remarkable vessel. With each staircase and each sliding door we pass, we venture deeper into the most critical areas of the ship.
In the machine control center, we've got this 3D screen that helps us check the ship's plans. The ship has a ton of stuff, so we use it to track all the pipes and air ducts. I can search for a specific circuit and see where it runs, and the other machine officers can do that too. It helps us locate things on the plans before we go find them on the ship. We always have a watch officer monitoring all the ship's parameters, like the refrigeration, oil transfer, diesel transfer, and steam boiler circuits. We control it all through these two screens here. Above that, I've got everything for managing the propulsion and electrical production. We mostly use the page that shows electrical production, which tells us how many generators are currently running, and right now it's 6.
To propel the Commandant Charcot, the designers chose to use LNG, liquefied natural gas.
Using the fuel with the lowest greenhouse gas emissions on this ship was a no-brainer to minimize our impact when sailing through these areas. At the moment, there are no fuels available on the market that are more environmentally friendly than natural gas. This helps decrease particle, sulfur, and nitrogen oxide emissions, as well as reduce CO2 emissions by approximately 25%.
In order to store a significant amount of liquefied natural gas on a cruise liner that's meant to navigate the frigid waters of the Arctic or Antarctic, the engineers had to come up with innovative solutions.
We had to build storage tanks to contain this natural gas, which is in liquid form. It is liquefied at minus 265 degrees Fahrenheit because in its liquid state, it occupies 600 times less space than in gaseous form.
2 gas tanks were built for the vessel with a priority of preventing liquefied gas from coming into contact with oxygen and with the hull of the ship.
In maritime terms, the biggest risk of a leak of liquefied gas is its cryogenic properties. At temperatures of at least minus 265 degrees, steel can break easily. That's why we take great care to prevent any mixing of natural gas with oxygen and to isolate the hull structure from the cold of the tank.
To design the tanks, the engineers used a membrane technology. The tank's interior first receives an insulation panel, followed by a composite material membrane, and then a second panel called the closing panel. On top of that is the primary membrane, made of a few millimeter thick embossed stainless steel, which gives it its characteristic folds. This membrane will come into direct contact with the gas and will be able to absorb the temperature changes caused by using liquefied gas at negative 265 degrees Fahrenheit. This technology is both highly reliable and very resistant.
This grooved membrane enables the tank to withstand up to 29 feet of deformation without rupturing if there's a collision with another vessel.
These 2 tanks are capable of holding 159,000 cubic feet of natural gas and can withstand pressures up to 2 bars, a world-first performance.
Thanks to this innovative feature on our natural gas storage tanks, our ship has become the world's first to navigate safely and with respect for the environment, while enjoying a natural gas autonomy of approximately 2 months.
The ship boasts a remarkable ability to produce its own energy for 2 months using natural gas stored in its 2 tanks. This is made possible by 6 powerful generators installed in 2 engine rooms adjacent to the tanks. Each room houses 3 generators, 1 with 10 V-cylinders and 2 with 14 V-cylinders. This massive machinery setup has been specially designed for the Commandant Charcot. The ship can run on just one of these 6 generators, providing redundancy for maintenance operations without compromising navigation. The engines are equipped with dual fuel technology, allowing them to run on natural gas or low-sulfur marine diesel. The engines of the 14 V-cylinders produce 7.7 megawatts, while those of the 10 V-cylinders produce 5.5 megawatts, which gives a total power output of 42 megawatts for the 6 engines. Each one is driving an alternator capable of generating a tremendous amount of electricity.
The ship can go as fast as 18 knots in open water, but during our cruises, we usually operate it at 9 to 12 knots, leaving us with a lot of extra power. We keep this power on board just in case we encounter any tough ice conditions that we need to navigate through.
The generators produce 11,000 volts of electricity, which are then distributed through a series of transformers to power all electrical equipment on board. 3,300 volts go to the Azipod propulsion system, while 690 are used by industrial devices such as pumps and fans. Laundry and kitchen facilities, as well as other equipment, use 400 volts, and other voltages may be available depending on the specific use. But with such a high production capacity, the machinery room generates more electricity than the ship requires. To make the most of this surplus, battery packs have been installed on the Commandant Charcot. These battery rooms are conveniently located next to the machinery control center.
We use the batteries as a buffer to handle all this huge amount of energy. That's where the hybrid part comes in, where we can generate even more power by storing it in the batteries.
Right now, we're on the ship that has the biggest battery pack installed on board. It weighs around 50 tons and can store up to 4.5 megawatt hours of electrical energy. This battery pack is capable of providing complete battery autonomy for up to 1 to 2 hours. We call it the zero-emission mode on board. We use it when the ship is docked, or we're navigating through environmentally sensitive areas where we want to avoid disturbing the wildlife by keeping the ship in a quiet mode of operation.
The number of operating generators, as well as the charging or discharging of the batteries, is dependent on the navigation conditions and the power needed by the Azipods. Throughout the voyage, the ship's chief engineer, Hugues de Camus, meticulously monitors the production of electricity needed for the ship to operate smoothly.
Currently, we have 2 generators operating at 50% capacity, Generator 1 and Generator 3. The battery is charged to 60%, which means it's nearly at full capacity and optimized for use. We're currently in ice mode, as indicated by the yellow light on the control panel, which means we're managing power consumption and motor usage specifically for icy conditions. However, the ice isn't very severe at the moment, so we're not anticipating any significant issues. I can monitor the propellers. Look at the curves, particularly the orange curve, which indicates the propeller's rotation speed, and the green curve, which indicates the torque exerted by the propeller in the water and on the ice if present. For example, we just hit a block of ice, and we can see that the torque increased while the speed decreased. This is common when a block of ice comes into contact with a propeller and momentarily stops it. Because the ice is soft, it doesn't take long to pass through, and the torque doesn't increase too much. So this is a typical figure when a block of ice comes into contact with a propeller.
At present, the ship is running with only 2 of its 6 generators. When the vessel is cruising in open water, the generators provide electricity to the azipods while charging the batteries at the same time. However, when the ship encounters thicker pack ice, the azipods' propellers push harder against the ice, increasing the power and energy required to move the ship forward. To prevent the generators from overloading, the batteries take over as soon as the generators go beyond 90% of their capacity, providing some of the electricity needed to run the azipods. A sophisticated system has been implemented on board the ship which has the ability to optimize energy consumption, resulting in a reduction of the amount of fuel required. Additionally, it's capable of extending the lifespan of the generators.
You can see its status here. It shows -15. That means the battery is currently being charged. It's the generator that's providing power to the battery. When the number is positive, it means the battery is providing power to the generator. When the batteries are being discharged, they help the ship, and when they're charging, they make the generators more efficient. The 2 battery packs together have the power of 1 generator. That's pretty impressive. We already have 6 generators on board, and with this battery pack, it's like we have a 7th generator. That's a huge amount of power.
When facing the thickest ice conditions, the Commandant Charcot vessel can count on a powerful system. All 6 generators and 2 battery packs can work in tandem, supplying maximum power to the 2 propulsion motors. This intelligent system prevents overloading the generators and allows the ship to confront even the most extreme situations. Thanks to this setup, the vessel was able to reach the geographic North Pole. However, when navigating these harsh conditions, the 2 azipods and their propellers face even greater challenges. The torque, which is required to break through the blocks of ice they encounter, reaches maximum levels.
So in this situation, the engines will be running at almost maximum capacity with frequent overloads. This means we're going to push the boat to its limits. It's kind of like a blender. If you fill it up with fruit and force it, it won't be able to turn. It will just heat up and eventually burn out. However, we have clearance to let it heat up a bit for a certain amount of time. We have systems that allow us to go up to 150% with torque management, which involves energy dissipation in batteries, energy recovery, or using resistors to dissipate the excess heat. Otherwise, the intensity would increase exponentially and the engine will burn out.
Hugues de Camus leads us into one of the vessel's 2 propulsion rooms. An ultra-secure location accessible only through a watertight and fire-resistant door. The circular shape of the azipod is clearly visible, along with the system that enables it to function. High-voltage electricity, up to 3,300 volts, is fed into the electric motors that drive the azipod propeller. 3 hydraulic motors on each side of the device are also noticeable. These 6 engines allow the captain to orient the azipod as desired from the bridge. Each propulsion room is positioned directly above one of the azipods, and the 2 rooms are completely isolated from each other.
What's unique about the design of this ship is that it has 2 completely separate engine rooms. This level of redundancy is in place to increase the ship's safety. It even extends to the azipod propulsion system. Each azipod has 2 half-electric motors. So if one fails or loses power, the propeller can still turn with the remaining half motor that is powered by another means. This level of redundancy requires a lot of wiring and piping throughout the entire ship, and it goes through different routes to increase safety in case of an accident. The ship can therefore be kept operational through all the electrical circuits and piping that have been designed for this purpose.
If one of the propulsion rooms experiences a malfunction, the Commandant Charcot can still navigate. The same level of redundancy extends to the engine rooms, where the generators are housed. Even if one of the rooms is affected by a fire or flooding, the ship can continue to operate with the other room without any issue. Additionally, the ship is equipped with extra fuel tanks carrying LS-MgO, a low-sulfur fuel that exceeds the standard requirements for fuels commonly used in the Navy, in case there is a problem with the storage tanks. This reserve guarantees a safe return to port in the event of gas supply issues. Another system specifically designed to ensure passenger safety in all circumstances is the ship's central heating.
The vessel is like a safety cocoon in a harsh environment. Outside, the temperature can drop down to -13, and it has even reached -18. If the heating system fails, I'm afraid the ship will become uninhabitable in just 2 hours. That's why it's of utmost importance to maintain the proper function of the central heating system.
To guarantee the ship's warmth, a smart heating system has been installed in the extension of the ship's generators.
The Commandant Charcot is an electrically powered ship with generators that run on natural gas to produce electricity. These engines are almost 50% efficient, which means that 50% of the energy from the fuel is lost as heat in the exhaust gases. Our objective is to recover this heat by using a hot water circuit to warm up potable water, swimming pools, laundry rooms, and kitchens, and thereby minimize onboard consumption as much as we can.
It is the pumps that moves hot water throughout the ship, serving as the main heating system. If they were to fail, the temperature inside the ship would drop incredibly fast. It's absolutely vital. I'd rather be put in the middle of a lion pack than at the North Pole without this. These pumps are the core of the ship's heating system, ensuring a comfortable environment on board. Each pump can heat the entire ship, and luckily we have 4 of them.
With cutting-edge propulsion technology and energy optimization systems, the Commandant Charcot can venture to the farthest corners of the Earth and sail solo for 2 months straight without jeopardizing the safety of the crew and passengers. It proved its remarkable abilities when it reached the geographic North Pole. Captain Etienne Garcia, along with Captain Marchessault, both experienced French naval commanders renowned for their proficiency in navigating icy waters, were at the helm during the full-scale test voyage. Their joint leadership made history.
We made it. We had dreamed about it. We've reached the 90th parallel. This is the first time a French vessel has reached the North Pole. It's a historic moment that we will accept with great humility.
The Commandant Charcot is the only cruise ship that can reach the North Pole right now. In fact, it was the first French ship ever to reach the geographic North Pole. For me, navigating through the polar waters is the most complicated type of navigation. But it's also incredibly thrilling. However, even when you're surrounded by 100% ice, you feel safe in a ship like the Commandant Charcot. It opens up a whole new world that wasn't accessible before.
The Commandant Charcot has been cruising for 10 days and is now heading south, sailing along the east coast of Spitsbergen Island. Its next destination, before returning to port, is a fjord near the Lillehookbreen Glacier, one of the largest in the archipelago. This area is pristine, an untouched and fragile wilderness, and the ship must navigate with the utmost discretion and respect to protect the environment.
When navigating through polar waters on the Commandant Charcot, the main goal is to minimize our impact on the environment. We pay special attention to the coastal ice that forms in fjords throughout the year and melts in the spring. It's the easiest to break, but we have to preserve it. The ice is vital to the ecosystem as it provides a platform for animals like seals and bears to hunt and raise their young. So we navigate through the drifting ice to access the edge of the coastal ice. Even though we have the ability to break through the ice with ease, we won't break through it. We choose to find a spot that won't compromise the ice's fragility. Despite our ability to go almost anywhere, we opt to be respectful and mindful of our surroundings.
To safeguard these delicate regions, the International Maritime Organization created the Polar Code. This code applies within two areas marked by boundaries situated at the 60th parallels, both north and south. Every vessel that crosses these lines must adhere to particular regulations when navigating through them. Managing water on board is one of the critical factors in complying with the Polar Code. A ship carrying over 400 people can be compared to a small city. The daily water consumption can reach a whopping 100 tons, with 25 tons being used for laundry, 10 to 15 for the kitchen, 10 tons for technical facilities and cleaning, and 50 as drinking water. To meet this demand, the ship is equipped with a system that can produce all the necessary water by treating seawater.
In the past, we used to bring plastic bottles of mineral water on board for serving to passengers as drinking water. But now, we've decided to completely eliminate plastic waste. So we pump seawater, filter it, and pass it through desalination units called osmotic purifiers. The resulting water is chlorinated, stored on board, and it's drinkable, although it has an unpleasant taste. To fix this, we've developed a special filter that removes anything that could give the water an unpleasant taste, including chlorine and any potential plastic or metallic tastes that might come from the pipes. After that, we bottle the water we produce on board in glass bottles, which we seal up.
The ship has 2 osmotic purifiers. Each one can generate 120 tons of drinkable water daily. This production capacity of 240 tons is over twice the amount needed. Additionally, Commander Charcot's zero waste policy mandates that no wastewater be released into the environment from the ship.
We have installed a wastewater treatment system on the ship to recycle and reuse water. This system processes gray water from the sinks and showers and black water from the toilets. Our approach is to mix these two types of water and send them through a filtration and bacteria treatment system, like an accelerated septic tank. By over-oxygenating the bacteria, they'll be highly effective in breaking down all the matter. The remaining residue will be filtered through ultrafiltration membranes, which also rely on bacteria. The clean effluent that comes out can be safely discharged or reused for laundry in the laundry room.
Commandant Charcot was designed to recycle all types of waste on board. A specific treatment system is used for each type. Cardboard is shredded, glass is crushed, and food waste is ground up and transported to a press for dehydration. The remaining pulp is then compacted and stored as frozen pellets.
The vessel is currently capable of operating independently in the polar region for 2 months without any waste discharge. All waste is unloaded on land outside of the polar regions when the ship arrives at the port.
The arrival of this extraordinary vessel in the world's most remote regions sparked an innovative idea among its designers to include scientific facilities on a cruise ship.
The Commandant Charcot was built to provide cruises to our passengers, but given its capability to reach extremely isolated areas, it can also be an incredible opportunity for scientific research.
The ship was built with special areas for scientific purposes, such as a dry lab, a wet lab near the water, and spaces in the hull to install different measurement systems for ocean currents or underwater mapping. Additionally, there is equipment available for measuring ice thickness, an onboard weather station, and several systems that continually measure seawater characteristics, such as temperature, salinity, and CO2 concentration.
Researchers accompany each cruise to gather water and ice samples, as well as to conduct atmospheric analyses.
Researchers find the data collected during the voyage to be extraordinary, since they are not easily accessible due to the remoteness of the areas. The Commandant Charcot provides them with this opportunity.
From the beginning, the Commandant Charcot project aimed to reduce the ship's environmental impact and create a positive impact by turning it into a scientific research platform. Scientists can conduct their research on the ship, which also enables passengers to participate and interact with them. It is a unique opportunity to become part of the history of navigation and scientific research in polar regions.
We explore some of the most isolated places, not just geographically, but also scientifically, as we collect data and gain a better understanding of how the world works. Charcot would have loved this ship. It would have been his dream come true. Gas propulsion, ice-breaking capabilities, and top-notch science facilities. We put all of that together, and it worked really well. The passengers are happy, and so are the scientists. And the crew are all incredibly proud to cruise on this amazing vessel. It's a tremendous achievement.
Commandant Charcot is the only French ship with such ice navigation capabilities. There are no other ships like it, and I think it will continue to be one of a kind for a while.
The Commandant Charcot has finished its cruise around Svalbard. Soon, it will set sail again with new passengers on board and will head to new locations in the north or to Antarctica near the South Pole. This amazing vessel will continue to uphold the century-old legacy of polar exploration for many years to come.